Hello and welcome to this. It's actually a new topic. Well, not new topic. It's a whole new area of maths we're going to be looking at now. This is the first topical video of decision. Okay, so D1. Now, we're going to start by looking at something called an algorithm. Now, don't get too worried. An algorithm is not as difficult as it sounds. Okay, it's just an algorithm is just a set of instructions. Basically, it's quite nice. The question tells you what to do. You just got to realise what form to write it in and follow the instructions like a robot. Okay, so basically what we're training you to be are the robots of the future. So welcome to D1. Alright, okay, so as I said, an algorithm is a set of instructions, okay, which you follow. The first one that you need to know about is something called a happy algorithm. And a happy algorithm is basically this is how it works. So you write down any integer, okay, so for example 70, you square its digits and find the sum of the squares. So for example, if it was 70 you were finding, it'd be 7 squared plus 0 squared, because obviously 7, 0 obviously make up 70. It's obviously not 7 plus 0, but you get the idea. Okay, and you continue doing that, and you can repeat until the answer is 1, in which case, if it does end up being 1, then the number is happy, or if you keep getting trapped in a cycle where you never get to 1, then the number is not happy, okay? So basically, that's just an algorithm, okay? Just a set of instructions, okay, that you follow. Okay, so let's go with the 70 idea, and I'll prove. So 70, is it a happy algorithm? Well, as I said, we square the individual numbers, okay? So we 7 squared plus 0 squared and find the sum, okay, which is obviously 49, and do the same with 49, okay, so you have 4 squared plus 9 squared, which is obviously 16 plus 81, okay, which is 97, okay, and then you do the same with 97, okay, so you do 9 squared plus 7 squared, which is obviously 81 plus 49, which is 130. Okay, do the same with 130, you do 1 squared plus 3 squared plus 0 squared, which is obviously 1 plus 9 plus 0, which is 10, square 10, so 1 squared plus 0 squared is 1, okay, so therefore we end up with 1. 70 is a happy number. Okay, so let's put a little smiley face next to it. Another little thumbs up there. Right, good art skills. It's a happy number. If you want to make it look like me, you can do a bit of that. Right? Okay, so that is a happy algorithm. Okay, and now let's do another one. Okay, 4. So if we do 4, it's obviously 4 squared, 16. You do 1 squared plus 6 squared. Okay, so it's 1 plus 36, which is 37. 3 squared plus 7 squared. Okay, so that's obviously 9 plus 49. Okay, which is obviously 58. 5 squared plus 8 squared. Okay, so it's 25 plus 8 squared is 64. Okay, so that is 89. Sorry, 89. Sorry, 89 even. And 8 squared. So my 8's come really wrong there. Plus 9 squared. Okay, which is actually 64 plus 81, which is 145. Okay, do the same with 145. Okay, and then you will get to a point if you do that where you get back to 4 squared is equal to 16. So if you carried on, follow that method, okay, squared 1, squared 4, and then added and squared 5, okay, you would end up, if you continued for that path, and you would get to that. So therefore 4 is unhappy. Okay, so as I said, that's just an example of a very basic algorithm. So it's just a set of instructions. Okay, so basically we're saying you get a number, you square the individual parts of that number, add it up, and if it ends up being 1, then it's happy. If it doesn't, and you're just stuck in a cycle, then it's unhappy. So that's a very basic example of an algorithm. Okay, it's just a set of instructions that you follow. However, you're not going to be asked something like that in the exam. Okay, because obviously this is A-level maths, and that's quite simple, even by decision standards. Okay, so you might get something a bit more like this. Okay, so if we say Okay, so this is the steps of an algorithm. So line 1 is let n equal 1, okay, a equal 1 and b equal 1. At line 2, you write down, no actually, sorry, no, you might not be told that, so line 2 might say c equals a plus b, okay, down this end of this. Okay, line 3 might say let n equal n plus 1 and a equal b, b equal c. Okay. 4, okay, if n is greater than 5, go to line 3. Oh, sorry, go to line 2. Sorry, I'm kind of missing out some of the lines that you won't be told, okay? And then number 5, if n equals 5, stop. Okay, so how would you follow this pattern? Okay, so basically, it's sort of, once you've completed this step, you go on to this step. Once you've completed this step, you go on to this step. Okay, once you've completed that step, you go on to step 4. Once you complete step 4, you go on to step 5. Okay, and so on. But if you get something like if n equals less than 5, go to line 2, and you keep repeating that pattern until you get to the end of the algorithm. But one major question, or the main question you should be asking, how the hell do we do all this? What, I mean, surely, how do we write it down? Yeah, very good. We can let c equals a plus b. But where do we all write that down? What does that make any sense at all? Well, I was missing out lines there on purpose, obviously, because we've got to create this kind of table, okay? And essentially, you do this for every single algorithm, which is like this. So, as we're told the values of n, a, b, okay, and we're also told the value of c in this one, and n equals n plus 1. So we have to write down n, a, b, and c, okay? And oh wait, I forgot to write print. That's great. That's just brilliant. To redo that again. Sorry, I'm not sure where I'm going to put this back in, but basically I made a little bit of a mess, so I've changed the question that I'm going to be doing, okay? So basically, we're told these steps, alright? We're told that P to be 30 and Q to be 9. And we're just asked to follow these steps. So input P, input Q, let this Z, which is just going to be another thing, okay, equal Q. If Z is greater than P, in other words, if Q is initially greater than P, then go to line 8, which says stop straight away. But if it isn't, okay, then you would follow this, so you'd print Z, I'm going to explain what that means in a minute. Then you would let the next Z value equal Z plus Q, and then go back to line 4 and continue until you eventually have to stop. Okay, and in essence, all the answers which you print for Z, which is why it's got it there, are the answers that you come up with, because obviously you're going to get to a point where you stop and you're right, well, what's the answer? It's everything you printed. Okay, it doesn't mean obviously take it, put it on a computer, send it to the local printer. Unfortunately, it doesn't mean that, because it doesn't mean you have any time to look at the answer, so unfortunately, it doesn't mean that. Okay, so the first thing we need to do is draw a table. Now, you might go, well, what is in this table that we draw? Well, it's pretty much everything that is described, okay? So we're described, there's a P in this, there's a Q, and there's a Z, alright? So that's all you write down. And we're told to print Z, but we just have to come up with another column for printing, okay? So we write P, Q, and Z, okay? And then obviously a print column. Alright? Probably could space out a little bit more actually. So P, Q, how much? Okay. So the first ones will let that P is 30 and Q is 9. Okay, so for each line, obviously we don't change P after we input it, so we keep writing 30 on each line for P, okay, or you could just put a little dash in each line, okay, it's up to you. Anyway, so let Z equal Q, so Q equals 9, Z equals 9, and then if Z is greater than P, which it isn't, go to line 8. So it isn't, so we just go to line 5 instead, and then we print Z. So we just write Z is equal to 9. That's your first line. Then you let Z equal Z plus Q. So let Z equal Z plus Q. So the next line for Z, so it's 9 plus 9, okay, which is obviously 18. You write in 9 and 30, and then we go back to line 4. If Z is greater than P, go to line 8. If it isn't, we print Z. Okay, so the next line will say Z is 18. Do this again, so 39. Then we do Z equals Z plus Q. So the next value for Z is Z plus Q, which is 18 plus 9, which is obviously 27. Okay, print that. Z equals 27, because when we go to line 4 and we follow that, we have to print it. Then we go to the next line. Okay, so we write in 39. We let Z equals Z plus Q. So Z equals 27 plus 9, which is 36. Go to line 4, and as Z is greater than P, we stop. Okay, so therefore our answers are Z equals 27, Z equals 18, and Z equals 9. Okay, and that is a very, very basic idea. So what we did, just to recap it, because I did go a little bit too fast there, is I wrote a table. Okay, this will always be in decision. It will always generally be the first question in the paper. Okay, so you will always be given a table. You have to draw it like we've done. Okay, but it's good knowledge to be able to, because if you could draw the table, you know what's going to be missing, what you need to fill in. Okay, so you don't have to rely on it on the day for it all to be there in case they don't give it you. Okay, so essentially what we did then was we created a line for each thing it mentioned. Okay, so P, Q, whatever it might be, and then we just followed the steps. And obviously, when we got to 7, we just ended up in this cycle going from 7 to 4, back down to 7, 4 to 7, back down to 7, until we reached this certain value. Okay, where Z was greater than P, and we stopped. Okay, as we were told. So it's just like basically you start and then you follow a method, and you continue following that method until you achieve something, and generally that's a number is bigger than something else, such as this. Okay, and then you would stop. Right. So it's a case of once you get through it. Now you will only get the marks in D1 for the correct answers. Okay, which is logical. So you won't really get any working marks unless if your working is wrong. Okay, if you work with wrong numbers, that's how kind of tight this is, and I'll correct myself if I'm wrong on the things above my head, which will obviously be off the screen, but yeah, you'll see it at the top of the screen. That's what I'm trying to say. Okay, so that is a basic algorithm. Now, obviously, in the exam, they're more likely to be a little bit different than that. Okay, so they might look like something like this. Now, this is going to be quite an attempt to draw, so I'm just going to do my own switcheroo again, pausing the video, coming back to it, and having a perfect diagram on there. So we'll just give myself a second. Hello, I'm not sure, as I said, where I've come from with this, but just put another question on the board. Now, this is something that you're more likely to see. Okay, so, excuse me, rather than that simple thing we were just looking at before. Okay, so, as I said, they will generally give you it in a flowchart. Now, you can quite clearly see we're not going to be going backwards in an endless cycle until we get an answer. So, it's just following steps, okay? So, this is something you will see in IT, okay? So we're given that S is equal to 25,000. Now later on in this question, because this is an actual past paper question, we are asked to do a few things with this, okay? And T, we're going to be told what T represents, etc. Okay, so the first part of this question, we're told that the first, sort of, obviously we go from start, and we input S, okay? Now they give you this table, and obviously I've not drawn in this, individual layers, but you get the idea, okay? So you would input S is 25,000, okay? So 25,000 in the S column. Then you would write T is equal to 0, okay? So in the T column you'd write 0. R is equal to S take 8,000. In other words, you write in that R is 25 take 8,000, which is quite clearly 17,000, okay? And then our next step was R bigger than O. And if it's not, then we go to the output and we just output that. But because it is, okay, we go in the yes column, therefore we say, well, in our next line of working, obviously you write yes in the R is bigger than 0, okay? You don't write anything in the output because we're not told to, we're only told at the end and we've not got there yet. So whenever you see something like r is r bigger than 0, then it starts to do another level of things. Once we go through each of the columns, like we've done here, once we've gone through, the first row of each column, okay, we've gone to the second row of each column. So our next one, if t is 0.2 times r, okay, so that'll be our next column. S is still 25,000, okay. T is 0.2 times r. In other words, it's 0.2 times 17,000, okay, which if you just sub in your calculator, just get my calculator out in a sec. I do apologise. Let's just get this damn calculator out. Basically, sub in, 17,000 times 0.2. Now, you might just want to write that raw figure in T, but so it's kind of up to you, really. So if you were to do that, you would get 3,400. Alright, and so 3,400. Alright. Now, our next column is r equals r, take 12,000, okay? Well, we do it from our previous value of r, alright? So r is equal to the previous value of r, take away 12,000, which is quite clearly 5,000, okay? And our next line says, well, is r bigger than 0? Well, yes it is, okay? So you just write yes in that column. The next line, t is equal to the previous value of t, plus 0.1 times r, okay? So in other words, the new value of t is 3,400, plus 0.1 times 5,000, which you would work out to be 4,450, okay? And we still write s as 25,000, that hasn't changed, okay? So it doesn't tell you to do anything with the s, you would just keep writing it as 25,000, or you could just put a dash under each one, okay, to signify it's the same as the one on top in some way, okay? So now we've done that, step out. Great, I've missed a step in my algorithm out. Alright, anyway, so, sorry, if that was your value for t, if that was the algorithm, okay, I've missed out a step in my algorithm that I've got in my textbook here, but because it tells you to output t, that is our value for t, okay, 4,450. And in this particular question, now it's completely irrelevant, so the step I've missed out would be making r, you would take away another 10,000 from r, or whatever it is, okay, so that r would end up becoming a negative figure and you'd stop when r is less than 0. Okay, but obviously I didn't have enough room. Okay, so anyway, because we've worked down, okay, so what does this actually show us? Well, we're told t represents the tax and s represents income. So write down the amount of income tax paid by a person with an annual salary of 25,000. Okay, well it's 4,450 because t represents tax. I mean, it's not 3,400 because we still had a few steps to go. We still had a bit of income to get rid of. Okay, so the answer would be 4,450, so that's the amount of tax this person paid. Okay, so that's what this algorithm shows. Find the maximum salary of a person who pays no tax. Well, now we don't know what this value of s is, obviously, because we've got to work it out. So we follow the flow chart, but when we get to the output t, we obviously know that that is the end. That is the amount of tax they pay. Okay, so we need some way, the shortest distance really, to go to the output t without taking away any tax. Okay, obviously, you know, not going through these values. Okay, so we need the shortest distance that we avoid any t subtractions. Okay, all right. So obviously the only one that we could do, well, we could go straight from the first no. Okay, so the first straight away before doing any calculations. If r isn't bigger, after doing a few calculations, if r is not bigger than 0, then that would be our tax, okay? So, if r is not bigger than 0, it says it's not bigger, it's bigger than, but it's more than and not equal to 0, okay? So, if it could be 0, in other words, r could be 0. So, therefore, the maximum that r could be is 0. So, if we use this equation, r is equal to s take 8,000 being equal to 0, quite clearly the S, the savings, the money, the income, is 8,000. Okay, so that would be your answer for part C. Now that's quite a quick question. That kind of covers all I wanted to go over for the introduction to algorithms. In the next video, we're going to be looking at something we call the quick sort method and the bubble algorithm. Okay, so I'm probably going with the bubble algorithm first, but anyway, I'll give you a bit of an insight into that in the next video. So thanks for watching. As I said, hopefully try to explain that in sort of roundabout way. Okay, so thanks for watching, and hopefully we'll see you in the next video. Hopefully won't be adding any more to this.